In this lecture, we are going to look at how to calculate returns in code. As usual, you can look at the title of the notebook to determine what notebook we are currently looking at. So we're going to start by downloading our dataset. This is the Kaggle dataset, although it doesn't really matter which dataset you choose at this point. Next, we're going to import pandas, numpy, and matplotlib. Next, we're going to load in the data using pd.readcsv, setting only parse dates equal to true, but not setting the date to be the index column. Next, we're going to extract a new data frame by filtering all the rows where the name is sbucks. We'll call this data frame sbucks. If we use the head command, we can see that this data appears as expected. Next, we can call the plot function on the close column to look at the sbucks stock price as a time series. Now, to get down to the real work, we know that in order to calculate the return, we need the current close price as well as the previous close price. Now, technically, all this information is already in the data frame, but not in the format we need. What we want to have is the previous close price in the same row as the close price. To do this, we can call the shift function. We pass in the value 1 to say that we want to shift the close column by 1. We'll assign this new column to be prevclose. If we use the head command again, we see that our new column, prevclose, has been created. Notice how all the items in the prevclose column are just the items from the close column shifted up by 1. Since there is nothing to shift up by 1 for the very first value, this value must necessarily be NaN. And one common question I get is, shouldn't we shift in the opposite direction? i.e., shouldn't the previous close go backwards and not forwards? I would urge you to think about this on your own if this is a question you have. Try to determine which direction is correct based on how you're going to calculate the returns. In the next block of code, we calculate the return. As discussed previously, that's the close column divided by the prevclose column and then minus 1. We'll assign this value to a column called return. Note the use of vectorized operations here. There's no need to do something like a for loop through each row, calculating the return one by one. If you're trained in programming, that's probably your first thought for how to calculate the return given a two-dimensional array of items, but luckily, pandas make this operation very easy by allowing us to calculate all of the returns at once. If we do a df.head again to see what our new data frame looks like, we see our return column. Note again how the first row is NaN. This must be the case since prevclose is NaN, and therefore it's not possible to calculate the return on this date. Also notice how small the returns are. As mentioned, financial engineers are pretty accustomed to working with very small numbers like this, and that's why we use units such as basis points. Note that there is an alternative, quicker way to calculate the return. I'm not as big a fan of this method for learning purposes, since it doesn't make you think about what calculations are happening. The way to do this is we call the %change function. We pass in the argument 1 to mean that we want to calculate the %change over one time step. Let's assign this to a new column called return2. If we do a df.head again, we see our new column return2. Upon inspection, we see that both the return and return2 columns are the same, verifying that our calculation of the return is correct. Although up until now we've been plotting time series, what we are often interested in when we look at returns is the distribution of returns. One quick visualization we can do to get a feel for the distribution of a set of numbers is the histogram. In pandas, this is very easy. All we need to do is call the hist function on our data frame or series object. We pass in the bins argument to specify how fine-grained we want the histogram to be. So as you can see, what we get is this typical bell-shaped curve. We'll discuss more about what this means in the coming lectures, but for now, this is good enough. Another thing we can do with our series of returns is calculate statistics, such as the sample mean and the sample variance. To do that, we simply call the mean function and the std function. The std function actually gives us the standard deviation, which is the square root of the variance. This is a bit better in this case, since the standard deviation has the same units as the original data. As you can see, the return is very small, very close to 0, and the standard deviation is also quite small, about 0.01. Now, since we learned about log returns as well, let's try doing the same process but on the log returns. Luckily, NumPy operations broadcast over pandas data structures, so all we need to do is take the return column, add 1, and call it np.log. There are other ways to do this as well, such as taking the log of the price and then taking the difference, but I'll leave that to you as an exercise. So let's do a df.head to see what we get. You recall that in our previous lecture on returns, I talked about how, when x is very small, it's approximately equal to log of 1 plus x. And we can see that kind of behavior here. Notice how the log returns are actually very close to the non-logged returns. They only differ in about the last 2 decimal places. Next, we're going to plot a histogram of our log returns using the hist function. As you can see, we get pretty much the exact same distribution that we got for the non-logged returns. You might want to try going back and forth between the 2 charts to verify that for yourself. Finally, we can calculate the sample mean and the sample standard deviation of the log return, again using the mean function and the std function. As before, we see that the mean is very close to 0, and the standard deviation is about 0.01.